Hi, good afternoon. This is basically a project that started because of Jan Zor's good friend of mine. And he was talking to people and they were wondering about NAT64 and the effects on both service providers and web hosters. So what's the problem? Two different protocols, but we see more and more networks where IPv6 only is run with NAT64. So this is mostly mobile operators doing it these days. Android has 464 XLAT. Apple just uses plain NAT64 detection. But some people do really strange stuff to their websites. And there are cases where things just break. So what do content providers know about the effect of what they host on people visiting their services from behind NAT64? And people who are willing to deploy NAT64, they might want to get an idea of, okay, if we deploy this technology, what's the effect going to be on our users? So that's why we started doing some testing. It got started by Jan, works for Internet Society. He has his own institute, and me doing the programming, and my girlfriend doing the logo. It's basically built on Jan's NAT64 testbed. He has a setup where he has different NAT64 implementations from different vendors, and people can just type in the right DNS server in their system and try them all out and compare them to each other and see what the effects are. So it's a public test. Everybody can use it. It's completely open. He has a setup using A10 boxes. He has Palo Alto boxes. He has Joule software implementation and the Cisco running. So everybody who wants to test with NAT64 can just use one of his setups. All the instructions are there. For the website tester we built, we're using the Joule implementation, so the third one on this list. This is the cluster in Jan's data center. He lives really close to a telco pop, and he just has a couple of racks with lots and lots of equipment and all the different implementations of, for example, NAT64 there. So just to give you an idea on the hardware we're running on. Now this is actually one of the biggest problems. Some people put really, really strange stuff in their DNS. I guess maybe the requirements to the customer say you have to support v6, so they just put some random quad A record in just to meet a requirement. Or they just don't know what they're doing, but we've seen things with v4 mapped addresses in there. We've seen linked local addresses in DNS. We've actually seen the NAT64 addresses, the 64 FF9B version. We've seen documentation prefixes in there. There must be more than just this, but we've seen really, really strange stuff. And there's a really big problem with this. And it's called happy eyeballs. The happy eyeballs algorithm for a dual stack visitor falls back to v4 really quickly. So even if somebody puts junk in their v6 DNS records, nobody notices because everything just falls back to v4 and it just looks right to the customer. So even when people put really bad stuff in their DNS, for most people, it'll still just work. Of course, if you're visiting from a v6 only environment, or such as one that uses NAT64, you only have v6. So you will not fall back with happy eyeballs to the v4 address. You will actually keep using the v6 record, and if that one's broken, the website will just be broken. So for normal dual stack customers, this stuff isn't a problem. For NAT64 networks, it is. So this is one example that's really confusing, because with www, you get proper v4 addresses. If you just type the domain name without www, you actually get the all zeros v6 address, which makes no sense whatsoever. But this is stuff you can actually see in real life. So what happens? If you actually want to run a NAT64 network, you have a DNS64 server that does the DNS mapping, you will have to configure it to ignore certain v6 addresses. Just pretend they don't exist and just provide a NAT64 mapping for those as well. So even if the website has a v6 quad A record, just ignore it, just use the v4 record and map to that because v6 is broken. This is an example of how you can do that. You can just say, okay, we have DNS64 in bind, but you can just exclude, for example, everything that's outside of the 2000/3 range. So this would fix it for your customers. So if you're deploying NAT64, this is what you want to do. But of course, in our test case, we don't want this. We actually want to show the cases where it breaks. So in our setup, we don't fix this. What you also need is the break DNSSEC bit, because of course DNSSEC is made for protecting the domain data, the DNS data. Except what you're doing with the DNS64 is creating fake records. So that's exactly what DNSSEC is trying to prevent. So if you are doing DNS64 mapping, you actually have to break DNSSEC, otherwise it won't create mapping records for DNSSEC signed zones. So it's a bit ugly. NAT64 is not the nicest technology, but it's used a lot, and this is what you have to deal with if you use it. I'll show you some examples of different cases where websites break and the different scenarios. This one, for example, is a website about firewalls. Still waiting for the timeout. Nothing's happening. And actually, it turns out that this website is really secure on v6 because their quad A record is : FFFF : some IP address. So on v6, it will never work. And in our NAT64 test case, like I said, if you're dual stacked, your Happy Eyeballs implementation in your browser will just try to connect to v6. They won't get a response in 200 milliseconds. It'll fall back to v4. Problem solved. But on NAT64, it will just break, and it will wait for that timeout. Another case we've seen, DNS is good, web server does respond to v6, except on v4 you get the website, and on v6 you get a hello world page or a simple error message or something like that. So, you know, it's actually too common, this. People configure the DNS and they configure the web server, but they don't actually put on the right website. And one of the reasons that this happens is that people, especially the NOCs of many companies, are v4 only. They do the web hosting on v6, but the office network is still v4. The people running the monitoring tools run it from a v4 network, so they don't even notice if their v6 setup is broken. There's another example. It's actually a geolocation based. On v4 you get the real website. On v6 you do get a website, but it doesn't show you any content because the content, it depends on geolocation. And apparently they don't properly do geolocation on v6. So the v6 website just can't give you any data because it can't determine where you're coming from. This is actually a confusing one. I have no idea why this happened, but this was a website that didn't have a quad A record, so it was v4 only. But if we access it through the NAT64 gateway, we got just the default Apache, hello, this is your Apache web server page. So this is a confusing one because it shouldn't even notice that there's a difference. So it should have just worked. So I still have to debug this one, see what the underlying reason is. But it's one of the cases we ran into. Now, this is also an interesting one. This one shows a website where the main website runs on v6. It doesn't. The images and all a lot of the styling and stuff like that are actually coming from a v4 only server. So the website runs partially on v6 only. So on normal IPv4 it just works. On NAT64 it works because NAT64 just makes sure that the v4 content is accessible. But on IPv6 only, the main website works, but all the images are broken. This is really sad. I mean, this website could very easily be completely v6 accessible if they fix those images. So getting there, but not quite. Same example, except here it's not the images, but it's actually the CSS, the styling that's missing. So content of the website works, but just plain old HTML. And like I said, if you put in a broken Quad A record, you get broken websites in these setups. This is actually a screenshot from the test site already. In the middle, you see the v4 only one. On the left, you see the NAT64 version. On the right, you see the v6 only version. And this is basically how it works. You just put in a URL, and you can see screenshots from the different versions side by side, so you can see what the result would be for a user. This one is actually, you can if you see at the bottom right, you see the 1% in the bar, which basically means that the web server responded to v6, and then it either redirected to some other URL or something like that, and that one broke. So the first URL works, but everything after that is broken. You can see it in the bottom. You can see all the resources, and you can see on the fourth line it says bad gateway, which is basically the feedback we got from our proxy server that said, okay, sorry, but I can't access this. So probably a redirect to a v4 only domain. And this is what it looks like if you actually look at the resources. You can see that on v4 only and NAT64, most of the resources, all the images and CSS and style sheets, all of that works. On v6 only, it starts well, but then breaks. So what are all the things we're actually testing? Well, like I said, we're testing on NAT64. We're testing on v6 only, because we think that even though that wasn't part of the original question, it's really important to test that, because that's ultimately where we want to go. And then we spent some time looking at all the different things we could test. We started out with just seeing if the main URL got us an HTML page. But then you go, okay, but what if there's redirects? What about the images? What about the resources? So in the end, what we did is test all of them. We run a browser, we make screenshots of every different version, we keep track of all the URLs it accessed, and try to match them together and compare them. And that's basically the service we built. So it's a NAT64 check. You can basically go there, you get this image. You can even filter on, like, for example, you only want to see sites that perform well on IPv6 only test cases. And you just put in a URL and you get this result. Like I said, in the middle you see the v4 only website. That one should be fine. I mean, we're assuming that people are actually testing their v4 setup. And then we use that as a baseline to test to look at the other two cases. So like I said, screenshots for both. If you move the mouse over the screenshot, you actually get an overlay image that shows the differences. So as you can see, these are quite similar, but the big image is missing on the NAT64 one. And if you move the mouse over the left part, it'll actually show you in high contrast the differences between the image, and the changes just jump out, so you can really easily see what's going on. Some of the test cases are much less obvious. Like it says, oh, there's only an 80% match between the websites, and they look quite similar, but it turns out that because of some image loading problems, one of them is actually 3 pixels lower than the other or something like that. So even those changes get picked up by the system. Like I said, in normal NAT64 scenarios, you really want to fix the broken v6 records. If people put junk in their DNS, you have to fix it for your users, because otherwise you're getting too many complaints. People will call the help desk, and that'll cost money. So most networks actively running a NAT64 setup will usually put in some filters to filter out the broken Quad A records. In this setup, we explicitly didn't do that. So if something is wrong, we'll just let it break. Better to show a broken website and give somebody the fake confidence that they think their setup is working. So technically, how do we actually build this? it's actually a cluster of servers. So we have a management server with a web interface that I've just shown you. We have a server that has only v4. We have a server that has only v6. And we have a server that has only v6 with a NAT64 in front of it. Depending on, we actually have two setups. One is run in Jan's lab, one is run in my lab. We are all running this of course, on virtual machines. We use Phantom.js, which is a command line browser. Doesn't have a graphical interface, but you can completely script it. So what we do is we open the URL, we get debugging output for all the requests it sends out. Then we actually make it take a screenshot, export the screenshot, and then we load everything together, do all the comparisons, and try to give some meaningful results from that. So basically, this is how it works. A couple of servers, some connected to v4, some connected to v6. Management server that controls all of them. And yeah, just feel free to use it. Just go to the website, type in a URL. You can type in any URL. It's not just in the beginning, we could only do like the home page, but now you can just put in any URL, run the test, rerun it if you want. So especially if you put in your website and you see some errors, try to fix them, rerun the test, and try to get everything up to 100% success rate. When you run the test, it might take a while before it actually shows results, and that's because we're testing quite a lot of websites and they're all in a queue. So once you type in a URL, it'll be put in the queue. It will show you when the test will start, is scheduled, when it's starting, and hopefully after a couple of minutes, you'll get the result. So start testing. Make sure your website isn't broken in these cases. I'm sure that most of you will have no problem with this, because I hope you all understand how the internet works and how that you shouldn't put bad stuff in quad A records and things like that. But you know, this is something useful for a lot of people. We also provide all the debug outputs. So if you go to the website, you can open the resources page, and there's actually a link that shows you all the debug output from the web browser. So if there's strange JavaScript errors, even those will be visible if you want to see them. And I see that actually I'm speaking way too quickly, and I'm already done 11 minutes before my deadline. So any questions on this? What do you think? Is this something useful? Should we expand it? Should we do other things? Are you surprised by the results? I don't see anybody running up to the microphone. Good. That's much more important than asking me questions.